In a solar system, not so many million years ago, there were 3 planets: Mars, Venus, and Earth. All 3 were affected by the sun. They heated up, and they all gave off thermal radiation. But because of their different atmospheres and distance from the sun, they all had different climates. Mars had a very thin atmosphere. All the sunlight it received during the day made it quite warm, but by night the heat could escape, leaving it a cold and desolate place. Venus, on the other hand, had a very dense atmosphere, almost entirely made up of carbon dioxide. Because of this, very little thermal radiation could escape, leaving the planet like an oven. Earth's atmosphere was a mixture of gases. Some thermal radiation escaped through the atmosphere, but some was trapped under the blanket of gases, which left the average temperature a pleasant 15 degrees Celsius, making it the perfect place for the emergence of life. And that's where the trouble began.
Hi, I'm David White, not forgetting my friend Rex here on the shoulder. What we've just heard described is an example of what scientists call the greenhouse effect. Now, let's face it, there's hardly a day that goes by without the greenhouse effect being featured in the news. It gets blamed for all the extreme weather we've been having, and even the politicians are starting to get in on the act. But if it's been around since our planet was formed, why is there so much fuss now? It doesn't sound very threatening, does it? Greenhouses are nice, warm places where we grow tomatoes. It doesn't sound half as bad as a hole in the ozone layer or acid rain. But seriously, if it's going to affect the way we live and, more importantly, the way our children live, then we really ought to know a bit more about it. In this program, we're going to discover exactly what the greenhouse effect is and what causes it. And we'll also be looking into that hole in the ozone layer. But let's go back a few thousand years first. If Earth was such an ideal place for life, perhaps we should take a closer look at that mixture of gases which blanketed the Earth and gave it its moderate climate.
Most of the Earth's atmosphere was made up of nitrogen and oxygen, which, fortunately for man, were very good to breathe. There were also small amounts of other gases, like carbon dioxide and methane. With so many oceans, lakes and rivers about, there was also quite a bit of water vapor in the atmosphere, caused by evaporation, some of which condensed to form clouds. The Earth's climate was also very conducive to plant growth, and great forests sprang up. Their growth over millions of years used some of the carbon dioxide in the atmosphere to make their branches and leaves. As the trees and plants died and rotted or were burned in natural forest fires, they returned carbon dioxide to the atmosphere. At the same time, some carbon dioxide, or CO2, was absorbed by the oceans and seas, keeping everything in balance. There were also many swamps and marshy areas which gave off methane. This was created by a fermentation process which took place at the bottom of marshes or where water had been allowed to become stagnant. There was also another source of methane, a rather unusual source in fact, from animals such as sheep, cows, buffalo, reindeer, and even from termites. Some of the methane was destroyed by reactions with sunlight, but the rest stayed in the atmosphere for quite a while.
So, a few thousand years ago, that was what Earth's atmosphere was like. About 78% of it was nitrogen, about 20% was oxygen, and the rest was a mixture including water vapor, carbon dioxide, and methane. So far, so good. What we need to understand now is how these gases cause the greenhouse effect. As we said earlier, a greenhouse effect doesn't sound very threatening. The other problem with a greenhouse is that it is actually a bad analogy to try to use to describe the effect. The analogy is that the glass in the greenhouse and the atmosphere of Earth act in a similar way, letting in solar radiation. Now, this is true in both cases, but it's the second part of the analogy that breaks down.
The wavelength of radiation given off by the sun is relatively short and passes mainly unhindered through the mixture of gases in the atmosphere. This radiation is absorbed at the Earth's surface, although some is reflected, especially by clouds and areas covered by snow. As the Earth heats up, radiation back to space occurs. Only this time, the wavelength is much longer. Some of the gases in the atmosphere are able to absorb the longer wavelength radiation and reduce the amount that would have escaped into space. Nitrogen and oxygen are rather simple molecules and do not absorb the radiation. But carbon dioxide, methane and water vapor are what help to keep the planet warm and are known as greenhouse gases. It's this effect which is referred to as the greenhouse effect.
So the greenhouse effect occurs when thermal radiation moving up from the surface of the Earth is absorbed by some of the gases in the atmosphere, which leads to an increase in the Earth's temperature. Now, where the analogy breaks down is that an unheated greenhouse stays warm because it provides shelter from the wind, protecting the plants, rather than exhibiting a true greenhouse effect. But if the greenhouse effect is a natural phenomenon, it's been around for thousands of years, what's happening to change the situation? There's a movie on down the road that may shed some light on the subject.
Man's first instinct was survival. But soon we began to control the environment, farming instead of hunting, living in communities, becoming a society. Gradually, man became civilized and multiplied. We learned to control fire and began burning down forests so that we could grow crops and farm more animals, which released more CO2 and more methane into the atmosphere. Then, man became inventive. We used fire to forge metals to make tools. We invented the wheel and began building machines. We discovered the power of wind and water, of steam, and then of electricity. We discovered oil and minerals beneath the earth and built more machines to dig them out. Then came factories, processing plants, mills and refineries, mass manufacturing of all manner of products that made life easier and more comfortable. Early forms of transport gave way to newer, more efficient methods, the motor car, the train and the plane. Man had become industrialized. But the coal we burnt in our power stations to generate electricity for industry and our homes released CO2. So did the petrol we used in our cars. The more factories and cars we had, the more CO2 was released. And as the population of the world grew, we needed more food. So man invented fertilizers to help him grow crops more effectively. But that introduced another problem. Fertilizers release nitrous oxide into the atmosphere, which is another greenhouse gas. In tropical areas, rice became the staple diet, and the number of paddy fields increased. But paddy fields act just like swamps, with methane escaping into the atmosphere as the rice shoots emerge. As the population of the Earth swelled, the world seemed to get smaller, as man developed faster means of transport and even more ingenious methods of communication, cleverer machines which needed more energy. So we burned more coal and more petrol. And we needed even more food. So we burned more forests, used more fertilizer, and farmed more animals and grew more rice. And all the time, we were increasing the amounts of greenhouse gases in the atmosphere. And then we invented the fridge and the hamburger, which in themselves weren't all that big a problem. The problem was the polystyrene container which the hamburger came in, and the liquid that was used to keep the fridge cool. The process of manufacturing products like polystyrene involves the release of chlorofluorocarbons, or CFCs. These CFCs are also used in cooling systems like refrigerators. CFCs are a real problem because they are 10,000 times more effective as a greenhouse gas than carbon dioxide. And unlike some of the other gases, they are not readily absorbed or destroyed by anything. So once they're in the atmosphere, there is nothing we can do about them. Now, you don't release CFCs into the atmosphere if you snap a polystyrene plate, but you could be releasing them every time you spray on your underarm deodorant, because some aerosol cans use CFCs as a propellant. So that's where we are today. Still searching for ways to make our lives easier and more convenient, and all the time there are more people needing more food, eating more hamburgers, demanding more products, driving more cars, using more electricity, burning more coal, releasing more carbon dioxide, removing more forests to use more land to grow more crops, eating more...
So from around the time of the Industrial Revolution, we've steadily been increasing the level of greenhouse gases in the atmosphere. The amount of carbon dioxide alone has increased by 25%. And the rate at which the world continues to generate greenhouse gases doesn't look like slowing down. In fact, if we look at the potential for industrial growth in the still developing countries, it is more than likely that we will dramatically increase the rate at which we release CO2 and other gases into the atmosphere. But the story isn't quite complete. You remember we talked about the hole in the ozone layer. Now let's see if that contributes to the greenhouse effect.
Ozone is created in urban and industrial areas by the action of sunlight on fossil fuel pollutants. So there's more of it generated in sunny Sydney than there is, say, in Moscow. Ozone formed in this way acts just like the other greenhouse gases, hovering around in the lower atmosphere and contributing to the increase in temperature. However, the ozone with the hole is quite different. Ozone also exists naturally in the upper atmosphere, where it acts as a shield, protecting the Earth from the sun's ultraviolet rays. The trouble is those CFCs again. Because they cannot be destroyed, they continually float around in the lower atmosphere. Eventually, some of them find their way through to the upper atmosphere, where they are affected by ultraviolet radiation. As a result, chlorine is released, which attacks, thins, and eventually destroys the protective ozone layer, creating a hole.
So although the holes in the ozone layer let in more heat from the sun's rays, they don't contribute directly to the greenhouse effect. In fact, the biggest threat from the holes in the ozone layer is that they're letting in more harmful UV radiation, which, as we all know in Australia, can lead to increased risk of skin cancer. So the greenhouse effect is an ongoing phenomenon. Greenhouse gases have controlled the climate of the Earth since the atmosphere was formed. Mankind's actions since then have accelerated the greenhouse warming effect. Now scientists say that the net result of the greenhouse effect will be that the temperature of the Earth will increase on average by 4 degrees centigrade over the next couple of generations. But what will that mean to us living in Australia? Well, the effects on the local environment are less easy to predict. What is certain is that the future will be different for all of us. The most obvious immediate effects of a global increase of 4 degrees centigrade will be the changes in weather and climatic conditions. This will soon impact on other areas such as agriculture, health, housing, animal populations and ecosystems, energy usage, recreation, and of course tourism. To lessen the impact in these areas, there'll need to be prompt planning and policy responses. Furthermore, to slow the greenhouse effect, more efficient use of energy will be called for, like the special light globes that draw only 17 watts but have the luminance of a 100-watt globe. We'll also need to consider different sources of energy generation. We've already committed ourselves to certain changes because of greenhouse gases we've released to date. Now that process is irreversible. Science has come up with some solutions, but most involve major changes in our lifestyles and the way we use the Earth's resources. It's up to us to determine whether we're prepared to make these changes and how we go about it. How we will be affected in the future will depend on how we react now. The time is right for considering our options.